The engine behind me is Babbage's difference engine number 2, designed by Charles Babbage, an English mathematician who is also known as the first computer pioneer. Babbage designed this machine between 1847 and 1849. Babbage, as we know, did not succeed in completing any of his own engines in their entirety, so there is no complete Babbage engine. This is the first physical realization of any of Babbage's complete designs in the metal. The engine itself weighs 5 tons. It consists of 8,000 parts made of bronze, cast iron and steel, and it measures 11 foot long and 8 foot high. It's operated by cranking a handle. What it does is it calculates and tabulates the value of any 7th order polynomial, a class of mathematical expressions, to 31 decimal places. It not only calculates that with unerring accuracy, it also prints an inked hard copy as a record of the results, and also produces what are called stereotype plates. That is, it impresses the results in soft material, plaster in this instance, so that you can make a printing plate automatically. Now, the purpose of all this was to eliminate the risk of human error in the calculation and production of printed mathematical tables. The machine is operated by cranking this handle. So you turn this handle, and each cycle of the engine, the machine produces one result. So you just keep cranking. You set the initial conditions up on the figure wheels, on the numbered wheels. You turn the handle. What happens when you turn the handle is it drives this cam stack. And if you like, this is the microprogram. This is the device that orchestrates all the internal motions of the machine to get it to form the repeated additions that are needed for the method of differences, which is the principle it is using. So you turn the handle, it turns these cam stacks. There are 28 separate cams, and that is what determines the internal timing and the orchestration of all the mechanical movements of the whole machine. So that's, if you like, the guts of the machine, the internal microprogram. And what the machine does is it adds a 31-digit number on one column, and it progresses through the machine, adding from column to column to column, and the tabular value, the result, ends up on the very last column, 31 digits. So you crank the handle. Each cycle of the engine, that's 4 turns of the handle, each cycle of the engine produces the next result on this column. So the end process, the end product of that whole process, is a 31-digit number on this column. So we take the 31-digit result from the end of the machine at the end of the cycle, and it is automatically transferred to this apparatus, which is the output apparatus. It does 2 things. It prints on hard copy, in inked hard copy, a 31-digit result. That's a checking copy, so that you know actually what you've calculated. At the same time, it impresses results on soft material in these trays. So inside there are things called stereotype punches, which are number wheels, which are lowered into the tray. The tray then moves, it lowers again, and so the lines build up. Firstly, it's on display here at the Computer History Museum for 1 year. It's on loan from the owner of the machine, which is Nathan Myhrvold, who commissioned the machine. He paid for the machine to be built. And so it's here for a year, and then it goes into his private collection. What we will do with it is demonstrate it for people. We'll work on it. It's a research machine, so it'll be adjusted and worked on. We'll get experience about how the thing operates. And also, part of the reason now that it is here and it does work, and we have for the first time a Babbage engine, the idea is to do some research and to say, was it a practical proposition? If Babbage had one, could they have successfully produced tables? Babbage was not an impractical dreamer. This machine works as he intended to work. But was the entire enterprise of using the infallibility of machinery to produce printed tables, was it realistic? Could it have been done? And for the first time in history, we were in a position to actually answer that question.